In this video, we're going to discuss my top 10 best practices for C# developers. Now, these are things that I do on a consistent basis to make my code better. Now, I've got a lot more than 10 best practices, but I think that if you master these 10, you'll set yourself up for success. On the other hand, if you ignore these best practices, you will almost assuredly get into trouble. In fact, when students approach me with a broken application, the most likely cause for their issue has to do with not following one of these best practices. Before we get started though, I want to let you know to stick around until the end. When I built this list, I actually identified 2 more best practices that are very important. They are a bit different though, so I've added them on as bonus best practices. So let's jump right in with best practice number 1, name things well. Here I have the new project window, which will actually create both the project and the solution. You get this by just hitting the new project button here. Now in here by default, the name for the project is Console Application 8 and the solution name is Console Application 8. Those are horrible names. And the reason why is because you don't understand what that really does. So for example, what's the difference between Console Application 8 and Console Application 6? You just don't know. And so instead we need to name this something more intelligent. So I start with the project name. Let's call this Console UI. Now what does that project name tell us? Well, it tells us this is the console part of the application and that it's a user interface. Now does it tell us what that user interface does? Not really. We know it's a console, we don't know what it does. So for example, it's not the guestbook console user interface. But in this case, we're doing a demo, and so we don't have a real specific purpose for our application. So I can call that Console UI. And in fact, Console UI can be a fine name for it if you'd like. Good naming is hard to do, but I encourage you to take the time to really think through what your piece or whatever you're going to be developing is going to do. In this case, it's our project, and so what's our project going to do? And start thinking that through and develop a name out of that that makes sense. Next is our solution name. And the solution name really should not match our project name. One of the most basic reasons why you shouldn't do that is because then you don't know what's the solution versus what's the project. 2 different things shouldn't have the same name. I know Microsoft defaulted this way. I wish they wouldn't, but because they do, we have to make sure that we pay attention and change the solution name. In this case, I'm going to call this solution C# best practices. Now also notice my naming convention. I'm using what's called Pascal case here, which means that every word gets a capital letter. So C# best and practices. So CSBP. That's a great naming convention that most people seem to use in the industry. And it's also encouraged by Microsoft. And what we do, we use Pascal casing for our project names, our solution names, our class names, our file names, and most other things. The only thing we don't use Pascal casing for is our variables and our parameters. And we'll look at that in a minute. And there are, of course, other little exceptions, but we're talking about in general. Now, the other thing to note here is I did not say C# and put the hashtag, the pound sign here, like that. And that just identifies one more thing you shouldn't do in naming, and that is you shouldn't include special characters or spaces. In some instances, they will allow you to put spaces in there and not throw an error, but just avoid it because it will cause some headaches down the road that you just weren't anticipating. So no spaces, no special characters. Avoid numbers if at all possible. Try and use words instead. There are cases where numbers are appropriate. I wouldn't lead with numbers and try to avoid numbers in general. So that's solution naming and project naming. I'll hit OK. And now notice that Microsoft uses these same naming conventions with a capital first letter for each of their class names, their namespace names, and their method names. We'll see more naming as we go, and I'll point out as we do some naming, but that's pretty much wraps up the naming. But before we go, I want to add one more project to our solution. And this time it's going to be a class library. Again, I will name it well. In this case, I actually name it library at the end. And the reason why is because it's a class library. And so my personal convention, this is not one that is necessarily a best practice, but it's a good idea to at least think through. My personal convention is to add library on the end of every class library. And here's the reason for that. If I go into the console UI and add a reference to this helper library, go to projects, solution, helper library, I will only check this box here to add that reference if the name includes library. You see, it doesn't say in here anywhere, this is a class library. It just says, here's one of the projects in your solution. So if I were to do this in reverse, the wrong way, and add a reference in my class library to my console application, which is something you shouldn't do. But if I were to do that, it says console UI. Now that UI tells me it's a user interface. I don't add references to user interfaces. Therefore, I'm in the wrong place and I hit cancel. So if I'm in the right place for references in the console UI, add a reference, it says library, I know it's just a double check to make sure that I know this is a class library. The other thing to note is when I created that class library, it automatically created a class for me called class 1. Now I really dislike that Microsoft does this. We don't need to have a default class in here, especially not one named class 1. Whenever you see a 1 at the end of a name, your first instinct should be to make sure you get it out of your application. So in this case, instead of trying to rename this, I just delete it. And the reason why is because if there's ever a problem with which way I rename it, I don't want to end up with a file name called class 1, even if the class itself is something different or any other weird issues. Therefore, whenever I create a class library, I delete class 1. And that's the basics for naming. My second best practice is to add one class per file. Let's look at what I mean. Over here in the helper library, if I right-click and say add class, let's add the person class. I'll make it public. Now this file here, person.cs, holds the person class. But what if I wanted to add another class? Let's say the guest class. I could say public class guest. Putting the guest class here is possible. This is fine as far as C# goes. It's valid code. But if you look over here on the right, where does the guest class reside? You can't really find it. Now, you can argue, well, but this makes sense for me because, but here's what I would encourage for a best practice. Don't do this. Instead, create a new class file for every class. So now we have a public class guest. Once I make it public, we have a public class guest in the guest file. Now, just by looking at the file structure, we know that the person class resides in the person file and the guest class resides in the guest file. This also illustrates one of our naming best practices again. Notice that I called this guest, that's singular, and person, that's also singular. That is because this class represents one instance of a person. So for example, if this class had a first name and a last name value that was storing, for person, each instance would represent one person. So Tim Corey would be one instance of that class, whereas Joe Smith would be a separate instance of that class. Therefore, the class name is singular. So we have good naming conventions, and we have one class per file. Let's move on to best practice number 3. Use properties, not public variables. Let's take a look at our person class we have open here. If we want this class to store data and want to expose that data to the outside world, we want to create a property. Now I use the snippet prop, P-R-O-P, and tab twice to create an auto property. This is the proper way to create a variable type object that will present data outside this class. So for example, if we're in the program.cs project and we were to say person, let's add the using statement there. So person first user equals new person, first user dot first name equals Tim. We're now using that property. Now, if you wanted to, you could say public string last name. That is a public variable. If you went back over to program.cs and said first user dot last name, notice first of all that the first name has a little wrench next to it, whereas last name has that little blue square next to it. Because these two are different. The first name is a property. The last name is a public variable. Now you can use these in a similar manner, and in some instances you couldn't tell a difference between the two in how you use them. However, this is not a good practice. Do not use public variables. The entire explanation of why this is a bad thing is outside the scope of this video. However, I can tell you there are instances where you'll run into where you can't use a public variable the way you want to. Instead, you need to create a public property. So now, first name and last name are both public properties. That also takes care of the basics of our person class. All right, best practice number 4. Methods should do one thing. And the key there is they should do one thing and one thing only. Let's go back to our example and move over to program.cs. And let's scope out what this program should actually do. So I'm going to wipe out our test data from our previous example. Let's scope out what this program is supposed to do. It's going to start by capturing a number of users. Let's go with peoples. Capture a number of people's names, and then loop through and say hi to them. So it's first going to capture a bunch of names, and then next it's going to loop through each name and say hi to them. Really, really simple stuff. But that's the overall goal of this program. And in fact, let's put these comments, let's move these up here instead. And we'll also fix that formatting. Now this is a sample application, so it's not going to do a whole lot of real world stuff. But instead this is just a demo to show what we could do with it. Now, the temptation here is to put all the code inside static void main. In fact, let's just kind of demo that. So first, let's create a list of person. I'll call it people. And again, back to our naming for a minute. This is a variable. It's a private variable. And so I name it using camel case. And camel case says that the first letter of the first word is lowercase. but every word after that, the first letter is capitalized. So for example, if I had two words here, say people who I like, that would be how it would be written out. Since it's only one word, it's all lowercase. Also note that it's plural, people, as in more than one. And the reason for this is because this variable is a list of type person, 0 or more people. Next, let's add a couple of sample records. Now, typically this is where you actually capture the people's information, but we're in the beginning stages of building this application, and so you want to have sample data in there to try things out. So let's just go ahead and create some sample data. So people.add new person, and we'll just copy that row a couple times. And there we go. We've added 3 people to our list. Next, we'll create our for each loop. And we're going to say, let's just do a console write line that says hello person.first name space person.last name. And so what's going to happen with that is we're going to first create the list of people, add the people to the list, and then loop through each person in the list and say hello and their full name. And of course, just for completeness, console.readline at the end so that the application can pause and let us see what's on the screen. And let's, again, this is the bad way of doing things. This is a poor example, but let's go ahead and demonstrate what this would look like. So hit start. And it says, hello, Tim Corey, hello, Sue Storm, and hello, Jill Jones. But I said this is the bad way of doing things, the poor way of doing things. And why is that? Well, again, our best practice is that methods should do one thing and one thing only. Well, this static void main right here is a method. What's its job? Well, right now, its job is to create a list, add people to the list, loop through each person, say hello to each person, and then pause the operation. That seems like more than one job. So let's refactor this in order to make it a little easier to work with, and also so that this static void main only has one job, and that job will be to quarterback the application. You see, the console application, static void main, is where we start and where we finish, meaning the application starts by calling static void main. Once static void main is done, the application closes. So its job is to just run the application. And so what we're going to do is take out any tasks or pieces that don't align with that just running the application. Let's start here with this list of person. Let's actually take this out of here and put it above, and we'll actually be specific here and say private. So this is a private list of person called people, but it lives at this level. It lives at the same level as static void main. And we'll need to make this static as well. So now we have our list outside of static void main declared so that any method can call this people list and use this people list. Well, what methods need to call that? Well, let's create a new method for these 3 rows right here. Let's call this private static void, meaning We only want people to call this that are inside this same class program. This is what we do for all of our methods inside of a console application. Void means it returns nothing, and we'll call it set up sample data. And this goes back again to our naming. We keep coming back to that naming best practice. Notice I call this setup sample data. Now, what do you think the method called setup sample data does? Well, it sets up sample data. In this case, these are the 3 sample records. We'll put them there. And now up here, we can call set up sample data. Next, let's get rid of this loop here. So let's create a private static void. We'll call this greet all the people. Again, what do you think this does? Well, it's going to greet each person. So we'll take this for each and put it down here. And then up here, we will say greet all the people. So now our static void main is just the quarterback. It calls methods until it's done calling methods, and then it says, okay, pause to let you see things, and we're done. So that's its job. The setup sample data method has one job, set up sample data. The greet all the people method has one job, loop through the people and greet them. Now this is a simplistic example, but notice how easy it is to read what static void main does. Set up sample, greet the people, done. And then look at each method and see how simple each of these are. They're very, very simplistic because they have one job and they do it well. When you break things down like this, it may seem simple, it may seem silly, but the reality is it makes for much easier to read code, which makes it much easier to debug. Also note that right now I'm using sample data. Well, I won't be using sample data all the time. In the future, I will capture user information. So instead of deleting this code or commenting it out, I just comment out this method. And now it's no longer being called. I can call a new method called ask for people information or something like that. But then if I want to test this application, maybe I found a bug and I don't want to go through and add all the data in order to populate it in order to then try out the bug, all I need to do is come back here and say, let's use the sample data again. It makes it very easy to switch from debug mode into a production mode. Just comment or uncomment a method and you have or don't have your sample data. And this example really leads into the next couple of best practices. So let's look at best practice number 6. Best practice number 6 is keep it simple. And what I mean by that is you really shouldn't write complex code. In fact, if you find code that's really, really complex and you think, man, this is really cool, pause for a minute. Think it through. Is there an easier, simpler way of accomplishing the same task? So for example, in this code here, I could have had all the code inside static void main like I used to. That was a little more complex because you had to read all those lines of code to figure out what's happening in the application. Whereas now, it's very simple to know what each piece does. But let's look down here as well. Down here, I'm using a for each. Well, a for each is a very, very simple statement. It says for each person in the people list. That's pretty understandable. Whereas you could say for I equals 0, I is less than people dot count, and I plus plus, and then do a console write line, and say hello, people, I, first name, space, people, last name, like so. This right here and this right here are really the same thing. The difference is that this one down here is a lot more complex. I'm creating a new variable. I'm counting. I'm making sure it's less than the count because the count is 0 based. And so if you have 3 items in the array, it's 0, 1, and 2. Therefore, if the count is 3, then really we have to go less than 3 because the one that says 3 isn't actually 3. It's a fourth one. You get the complexity? Okay, trying to figure out which place you're in the array. All this kind of stuff is complex. There's an easier way of doing this that's simpler. It's also easier to read. What's even worse is when people get these great ideas of how to make this for loop even cooler. For example, saying things like I is people.count minus 1, and where I is greater than or equal to 0. And instead of I plus plus, it's I minus minus. Guess what? That would work too. It actually count through the array backwards, or through the list backwards. But guess what? That's even more complex. We don't want to do that. If at all possible, let's stick with the very simplistic and easy to use for each. So there's simplicity in making small methods that do one thing. And there's also simplicity in what you choose to use or not use. And I get this question a lot from new beginners in software development. They ask me questions that are really questions that only a senior level developer should even be thinking about. A simple example might be they ask me about abstract classes. And they might say, well, how do I use an abstract class? And generally my advice is, why are you even asking? Because typically, if you're asking about an abstract class, it's because you read about it or learned about it in some type of tutorial, but you have no clue why it's even useful. And it is good to learn about these things and learn their usefulness, but that really isn't something you need to do until after you've mastered a lot more topics. My advice is master the basics, because the reality is the basics are what you're going to need to use most of the time. The complexity that some of these larger or broader topics bring in, like abstract classes or virtual interfaces, the complexity they bring in often doesn't help you, and sometimes it really hurts the readability and understandability of what's going on in your code. So for the sake of the next person who's going to read your code, try and keep it as simple as possible. It makes it much easier to understand and much easier to debug. The next best practice is number 7, be consistent. This is one that often gets misunderstood. The first part of consistency is doing things the same way you always do them. For example, down here I have a for each, and I said var person in people. I could have said person in people. Either one works. So if I was going to do another for each loop, I wouldn't say person like so. Now, obviously I wouldn't have 2 for each loops right after each other to do the same thing. But notice how this one uses var and this one uses person. That's an inconsistency. If I'm going to do it one way, I'm going to do that same way each time. The same is true for how I name things. For example, helper library. Well, if I am going to add a new class library, I will call it something library. I won't call it something code file, because I established that I always name my class libraries with an extension of library. So that's the first part of consistency. And programming, especially in C#, is all about attention to detail. So that's one of those details that really help you in the process. And the reason why this is a best practice is because that way it's much easier to visually spot an issue. If something is different than it normally is, you can look at that and see, why is this different? And maybe identify a problem. But the other part of consistency is conforming to whatever standard you are working with. So for example, if you're working in a company where you're working on an existing application, you may love my idea of this library being the end name of any class library. But if your company already has 3 class libraries and each of them ends in code bin, then you shouldn't name your class library with an ending of library. You should name it with the ending of code bin. Now sure, that's not what I'd recommend if you're starting out fresh. But if you're working in an existing system, you need to pattern your code off of the set standard for the rest of the code. So there's consistency first in how you do things, doing things the same way every time. But then part of that consistency is doing the things the same way that the rest of your team does. And so sometimes you actually do things in a way that's quote unquote worse than what you know you could do. And that's actually better. And it sounds wrong, but really fitting in with a current code base is more important than forcing your way or your style in the new parts. Now, with that being said, I do say that if you can enact change, it's a good thing. So for example, if you can say, hey, I've looked at our coding standards and these things bother me, or these things I think should be different. If the whole team gets on board with that, that's something you can work to evolve your code base to take into account. But don't just blindly make your own choices and say, well, I'm following best practices, because you're not. So be consistent, but be consistent inside your organization or your code group. Now, this next best practice is going to ruffle some feathers. Number 8 is use curly braces for if statements. And what do I mean by that? Well, let's take this example here. I'm actually going to cut this out for now. And I'm going to say if person.firstname equals Tim, and I'll paste it back in and say, instead of hello Tim Corey, I'm going to say hello Mr. Corey. I could say else just use the regular hello first space last name. So hello Sue Storm or hello Jill Jones. Now notice that I don't have any curly braces after my if or my else. This is accepted practice in a lot of areas. The idea is that if you don't have curly braces, the next line and only the next line is attached to that item. So for example, this line right here is attached to the if, whereas this line is attached to the else. So if person.firstname equals Tim, we're going to say hello Mr. Corey. Otherwise, we're going to say hello Sue Storm or hello Jill Jones. Now here's the problem with this, and this is where it really bugs me, especially when you're first starting out, but even later. If you decide, you know what, I want to say something else to Tim, we're going to say hello Mr. Corey, and then in the next line we're going to say, how are you doing? Typically you'd think, well, I'm going to say, how are you doing? Now you may notice that the indentation is weird, and you say, well, I'll just go ahead and tab that. But even if you don't, it doesn't really matter. Notice this red squiggly here. It actually tells me expected a closing curly brace. And if I were to run this, I have build errors. And let's see what those errors are. Curly brace expected. Well, even if I put one there, that's not really going to help me, because it still says I've got something else expected because I just closed the for each, and that's not right. So what's the problem here? Well, the problem is that this is no longer associated with the if statement. It will always run. In fact, if we didn't have this else statement here, we would have no error. And let's run this. Hello, Mr. Corey. How are you doing? How are you doing? How are you doing? I have 3 how are you doings. I have 3 people. Why is that? Well, because if the person's first name is Tim, I say, hello, Mr. Corey, that first line. But this next line isn't associated with the if statement. It runs every time. Therefore, I ask everyone how they're doing, including Tim, Sue, and Jill. If I had curly braces, it'd be very easy to understand that I'm only asking Tim, I'm only checking Tim, and if it is Tim, then I say, how are you doing? So if I do that, I only get, hello, Mr. Corey, how are you doing once, because the other 2, Sue and Jill, don't get asked how they're doing. With curly braces, it's very easy to understand what the scope is of that particular statement. Now, you may say, well, I only have 1 line. And that's true. But maybe tomorrow you want to add that second line in. And I know this stirs some controversy. I know some people really love having that one-liner with no curly braces in there. My thing is this. It doesn't hurt anything. Now, I know it's a little less typing to do it the one-liner way. But here's a thought. Use a snippet. IF, tab twice. Look what happened. It gave me not only my parens, but also my curly braces. In fact, if I were to say person.firstname double equals Tim and I hit enter, now my cursor is even between those curly braces. And so I didn't really have to type those out anyways. So my encouragement to you is to use the curly braces for every if statement. Don't try and shortcut it and do the one-liners. Again, these aren't requirements. These are best practices. In fact, these are my best practices. It's definitely an opinion. Our next best practice is number 9, concatenating strings with $sign. So what do I mean by this? Well, I've already demoed it once here. And what this does is it takes this part of the string, hello, Mr. and space, and then it adds in, using these curly braces, it adds in a piece of C# code. So all of this gets joined into one string because I put the $sign in front of the double quotes. A different way of doing this, and let's do this right above, I could have said, double quotes, hello, Mr., space, and double quotes, plus person.last name. And that is functionally equivalent, as far as the outcome at least, with this. The difference is the memory consumption that this takes versus this. This right here is an efficient process. This right here is a very inefficient process. Whenever you're talking about adding strings together, my encouragement is if it's all in one line. So for example, if you were going to say string test equals hello space plus person.firstname plus space plus person.lastname plus exclamation point, like that. If you're doing something like this, where you're building a string all in one line or in a couple lines, and then you are splitting that back out or using that, my encouragement is instead to do the $sign methodology. So string better test equals $sign. Do both your double quotes and your semicolon just to complete that line. But then come back and say hello space curly brace person.firstname curly brace closed space curly brace, person dot last name, close curly brace, and then exclamation point. Now, first of all, this is a little easier to read, but it's also more efficient than this is. Now, we used to use string.format, and we still can, but this $sign method has really taken over the string.format's place. It's just really easy to do, and it's really efficient. The other part, though, strings being efficient or inefficient, is in loops. Let's just create a private static void string demo method. And this is just for demo purposes. Let's say we're going to create a string. We'll call it just S. Not a great name, but it's good for demo. And we'll start that off with just an empty string. And then we have this for loop where we're going to say that, let's go with 100,000. So this is obviously a contrived example, but in this example, we're going to loop through 100,000 times and add to string just a simple hi. We'll put a space at the end of it. It's going to say hi, 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 hi 100,000 times. This will be horribly inefficient. Just to prove this, let's just do a console write line where we say datetime.now .to long time string. Now, this is not the most efficient way of timing your methods. It's just for demonstration purposes. But if we were to run this, so let's go ahead and put this method up here. And I'll actually even comment out my other methods, just so we're doing a good test. I'll call that. Let's make sure we have everything taken care of. It's going to write out the start time, and then it's going to write out the end time. And in between, we're going to do this for loop where we append something to S. If we were to run this, it's still thinking. There we go. It took approximately 6 seconds. Now, in computer terms, that's forever, especially since this application is very, very simple. It doesn't do a whole lot. Now, some of you may say, well, this S equals S plus is probably a problem. Instead, we could say plus equals. And that does something very similar. It takes the value of S, adds hi to it, and stores that new value back into S. It's the same basic thing. If we were to run this, it's still about 6 seconds. So that wasn't the problem. So instead, if you're going through a loop like this, the better practice, if it's very, very large. Now, if you're going through a loop of 5 things, 8 things, this probably isn't worth it. But if you're not sure, or if the loop might get larger, use a string builder. A string builder, I won't go into all the details of string builder, but basically it's a instantiated class. And so you say string builder, the name equals new string builder. And then here, instead of doing our plus equals, we would say sb.append hi. Now this is going to take hi and append it to our string. Our string will look the exact same as this S variable would have looked. Now the only difference with string builder is when you want it to be an actual string, you have to say .toString. So if down here I want to say sb.toString in order to get the string equivalent. But we're not printing it out, we're just storing it. Let's run this application. Did you catch that? Same exact time. Let's just show off, let's do 1,000,000. So 10 times as many as this method right here. 10 times as many. It still doesn't show a difference in our start and end time. So whereas this method would have taken approximately a minute probably, this method still does it within the same second. And we can keep going adding zeros on here, and it'll take a while before you see any difference. There's a little bit of a difference there with 10 million. Let's do 100 million. Okay, so at 100 million, it took 2 seconds. That is compared to 100,000 taking 3 times as long. So as you can see, how you deal with strings and adding strings together is important. In the case of just adding a string together for one line, use the $ methodology. If you're going to do a loop, where there's a number of strings you're going to add together, like this as example, instead use a string builder. And that will make your application much more efficient. And the last of our top 10 best practices for C# is avoid global variables. I'm not really going to demo this, but basically the idea is that when you first start out, you think, man, I have to have this information everywhere. And so you make everything global, meaning you allow everyone to see your variable across all different classes and programs. Because you think, well, I need for the person class, the guest class, to see my list of person called people. And really the answer is no, you don't. If the guest class, for whatever reason, needed to see a list that was somewhere else, you can pass that list along. It will even pass efficiently. So if you get tempted to create a global variable, think of how you can do it a different way. Now there's sometimes you say, well, but I have certain setup information. For example, where my text files are that I store log information in. That kind of information needs to be accessible across the entire application. Well, in that kind of case, you would use the app.config file and store information in here. And there's 2 reasons for that. 1 is everywhere has access to this file. And 2, you can change this file at runtime, meaning you don't have to recompile your application to change the values here. Now the bonus here is that this information doesn't live in memory. See, if you have a lot of global variables, you clog up a lot of memory that really isn't necessary. You need to adopt the idea of just in time, meaning I don't worry about information until just when I need it. And then I ask for it, I get it, I use it, I throw it away. That's how Microsoft deals with all of our variables. For example, this variable s right here. If I were to be using this, and let's just uncomment this to pretend like I am, and let's take out a few zeros just in case I accidentally run this. If I were to use this variable here, by the time we get to here, that variable is gone. Microsoft has said, we declare it right here, we use it in this for loop, but by the time we're done with for loop, we don't use it again. Therefore, I can get rid of it at this point in the code right here, line 48. Microsoft's very efficient about that kind of thing. So if we create a public variable, a global variable, that everyone can see and the whole application can use, Microsoft can't get rid of it. Therefore, it stays in memory and clogs things up. Now, before we go on, there are some of you that are going nuts right now. You've probably been yelling at your screen and saying, you missed one. I went through the entire top 10 list and didn't do number 5. So let's get back to number 5. Number 5 is use the public modifier only when necessary. And this actually ties into our global variables idea. Notice here on my methods, I have private static void setup sample data, private static void string demo method. Why are these methods private? Well, because there's no need for them to be public. What's the difference? Well, a public method can be seen by other classes outside of this class right here. If I make them private, only this class can access them. Well, there's no need to set up sample data for this class outside of this class. Therefore, it's private. And what I'd encourage is you to think a private first mindset. The idea that by default, you make everything private and then only change things to public when you say, yep, I need to have access to that outside of this class. For example, in the person class, we have this property, first name, and this one called last name. Well, we need to have access to these properties outside of the person class. Therefore, they're public. So those are my top 10 Best practices for C# developers. Number 1, name things well. Number 2, use one class per file. Number 3, use properties, not public variables. Number 4, methods should do only one thing. Number 5, the one we skipped, use public modifiers only when necessary. Number 6, keep it simple. Number 7, be consistent. Number 8, use those curly braces for if statements. Number 9, concatenate strings using that $ method. And number 10, avoid global variables. But wait, don't forget, I've got 2 more that are really bonus best practices. And these 2 aren't really code related necessarily, but I find that they're very, very important. And our first bonus best practice is never trust the user. I know that sounds pessimistic. I know that sounds antagonistic, but trust me, don't trust them. If you ask a user for their age, you will expect back a number. So if you ask a person for their age and they say 21, you expect the number 21. But some users, and not all of them, but there will be a user, they will type out TWENTY space ONE. Now that's a number and that's their age, but it's not a numeric value they've given you back. It's a string that represents a numeric value. So if you're expecting a number back in, you're going to be disappointed. This is the type of information that blows up projects. If you trust that the user is going to give you good input, you will only test your application using good input. Instead, build your application as though the users are out to get you, and try to figure out what they might do that's unexpected, and then make sure your application can handle it. So that's bonus best practice number 1. Never trust the user. And the second bonus best practice is plan before you build. Whenever I demo a full application where I build out from start to finish a project, and I've got one coming up soon for this channel, but whenever I do that, I spend a lot of time at the very beginning laying out the plan. Now I know your first instinct is to start coding. In fact, that's often my first instinct. I look at a project and I say, ooh, I know how to do that, or I know how to do most of that, or I know how to do this part of that. And so I'll go off and start writing code. The problem is that you back yourself into a corner if you don't plan before you build. I'm a certified project manager. That's one of the things that I am. And the project management guide, the guide that tells project managers how to manage a project in general, has this layout for the 5 major steps of a project. And so those major steps are initialization, and then planning, executing, monitoring, and then wrapping up or closing the project. So under those 5 major areas, the first one is just setting things up, or getting the initial requirements. But then number 2 is planning. Under that, the project management guide lays out 21 steps that have to happen before you can move to the next phase, which is actual execution of the plan. So 21 steps have to happen before you execute. When you execute, there are only 7 steps. Now you see that relationship? As project managers, we've learned that in planning, you make the project easier. This is doubly so when it comes to writing code. If you just start writing code, you will not think through all of the different areas. In my start to finish projects or demos, I go through the 5 steps of planning before we even start writing code. Before we open up Visual Studio, we go through the 5 steps of planning. And if you want to see that in more depth, I would say subscribe to this channel, but also get on my mailing list. And there'll be a link down below in the description to get on the mailing list. Because on the mailing list, you'll get first-hand updates of when new things come out. And one of the new things that's coming out really soon is my start to finish mini course for YouTube. And in that, I go through developing an application from an idea all the way through to a fully working application. And in there, we'll go over those 5 steps to plan out your application. These are the same 5 steps I use in my day job. These are the 5 same steps that I've used for years because they're that important. And of all the best practices on this entire video, the one that's most important, the one that I would encourage you, if you take away one thing, it's this: plan before you build. So that's it. That's my top 10. They're my bonus 2. And like I said, these are only the top 10. I have a lot more best practices, but these are the top 10 that I look back at all the time. So I have a question for you. Which best practices do you think should be added to this list? Or which ones do you think, man, that one really helps me out? Go ahead and leave a comment down below and let me know. I'd love to start a discussion on that. Also, don't forget to subscribe if you haven't already, and make sure to get on that mailing list. And I really push that mailing list not because I want to spam you. In fact, I really try hard not to send any more emails than is absolutely necessary. But what I do is I give out bonuses every once in a while to my subscribers, to my email subscribers. One of the upcoming bonuses is that when I release that start to finish course, I'm also going to be giving away or releasing a bonus package along with it. And that bonus package will allow you to download the videos. It will give you a companion guide and a whole bunch of other fun stuff. Now that's going to be a small cost, but if you're on my mailing list, you'll get a discount. So just make sure you keep an eye on that. Make sure you sign up and also start that dialogue via email. If you have questions, if you have suggestions for new videos, please let me know. Well, that's all for this video. I hope this was helpful for you. And as always, I am Tim Corey.